the other day. Before, when we had class, I think I told you how, did I tell you how at the end of the year you give me 2 letters, one for next year's kids and one for me? Yes, no? Okay, so every year, and I put them together, and they look like a book like this. This is one year I have, I think, 7 or 8 of these now. But in any case, and you all will be going through and doing them as well. There's always some stuff, we'll say it this way. I like things to at least be a little visually entertaining. And so I have this as a PDF. I scan most of them and we'll send it out to you. But I said to the kids, make sure that you go and give me something that's a little bit interesting in their letters to you. And you can go through and read them all. They're not for me, they're for you. Some speak wonderfully about what happened during the year, but some don't. But, like, in all honesty, if we were going to look, in terms of if I handed this to you, right, I like to have things have a little bit of flair to them. So, like, if I see this, am I going to really, on a 300-page thing, am I going to stop and read this page? Probably. But I wanted to show you, because some people, that's the weird thing I'm spending. Show me what's enough for them. There was somebody like that we had last year that was quite obsessed with Taylor Swift, so somehow writing about math class made me think of Taylor Swift, and we put in about 45 pictures. This was one of my favorites. I didn't like it because they talked badly about another teacher. You can talk badly about me all you want, but they talked badly about another teacher. But this was their message to you. It says, "Be afraid," and it looks like it's written in blood on the paper, which was Enriched. If somebody was trying to find this person, this was one that I actually read because I said, you have to give me something more. Like, they actually wrote, this is 1, 2, 3 pages of like 12-point font, not double spaced. They had a lot to say, and this is not very flattering of me, but it was actually, I put it in there because it A, changed how I did things a little bit, but B, at the end, they talked, this was the person who went through and watched, because getting called on in class was caused so much anxiety to them, that they literally would go through and find the video from the year before and watch that so they knew what the answers were. That way when they got called on, they knew what they were doing. I'm trying to find those ones. Like this, I'd stop and read. Here's the one. Some person put Tupac on there. Why? One person in here sprayed theirs with perfume. I don't know why either, because I'm like, wow, like it actually smelled kind of bad. There's some person though. Oh, this one. So me, who knows who Dr. Enk is? Or let's say if you know who these people are. Dr. Enk, Miss Julian, the other one. Or Miss Jockman. Raise your hand. Or if you know who Miss Swinson is. Okay. All of us are in this thing through New York State, called New York State Master Teacher College, because I'm kind of boring. On the weekends, sometimes, like once or twice a month, we get together and talk about how to make, like, to push you guys a little bit further in math, and we share projects and stuff. But in any case, it's kind of a big deal, because they only take like 6 or 7% of all the people who apply. But in any case, so I said, make yours interesting to look at. And I'm a very narcissistic person as well. You will hear me talk all the time about how amazing I am and everything. So I can't think, at first I thought I was a little disturbed by the fact that they did this. But when you're in Master Teacher College, you have to like have actual, like, they publish it from the state, so I had to go get my picture taken. But in any case, somehow this person, this may be the best background of any picture, or sorry, of any page in this book. They wrote there, this was their page. I don't even know what it says because I get so distracted by how good looking the background is. But in any case, if you ever have a minute or two, I strongly encourage you to go through and read what they say, because every year, the kids that go through and do it reference how good it was, not to like fall behind. Again, I'm very quirky. You will notice there are a lot of high pressure situations that you get put in class here, like a timed assessment. In the beginning, a lot of people freak out. The reason that you have a timed assessment is to get you ready for life. You're supposed to feel a little bit of pressure and urgency when you're going through and doing your assignments. I think you guys already have your first assignment. Actually, do you? Yes, your first assessment's already in, and you'll get that back before you go through and leave today. We left off last time that we had class. Let's bounce over, please, to, we'll do one thing. Let's start off, page 6, yeah. So, we're going to start off, now I'll give you a hint, the stuff that's important that's not currently on your paper is the stuff with the giant blinking lights next to it. You need to know what the perfect cube numbers are, and a number that's a perfect cube is a number you get by multiplying the number by itself 3 times. So a perfect cube number, 1, yes, is a perfect cube, it's a perfect square, it's 1,000 different things. It's neither prime nor composite. But 1 is also a perfect cube, but we never list that out. 2 to the 3rd power is going to be 8. 3 to the 3rd is not 9, it's 27. 4 to the 3rd, which is 4 times 4 times 4, or 16 times 4, is going to go through and give you 64. 5 to the 3rd is 125. 6 to the 3rd is 216. 7 to the 3rd is 343, and so on. So it's expected that you would be able to easily recognize all of those numbers. Now, this I'm pretty sure is new for you this year. You all should know the sum and difference of perfect squares. That factorization pattern is one that you did back in, I think, back when you took Algebra 1. This stuff is new for you. Not only can you take a difference of perfect squares and factor it down, you can take a difference of perfect cubes and factor it down. And the formula is what's up there now, so you're going to want to make sure that you get this down as well. And the formula is, it factors down into a binomial times a trinomial. You need to know that there's a binomial and a trinomial. If it starts off with a minus, you're going to have the signs to fill in are going to be minus, plus, plus. So between the binomial is a minus, and separating the trinomial is going to be 2 pluses. And it goes left, right, left squared, left, right, and then right squared. And we'll see it. It's a lot easier to see in practice when you go through and do it. But for now, make sure that you have this piece down. Like we did the other day, we'll go through and examine and say, well, on some of these questions, we take this baby step and maybe you don't think you need it. But take a look at question A. We're going to factor this down. You have to ask yourself, is the left and the right, are those perfect squares? Yes or no? Are these perfect squares? No. Are they perfect cubes? What times itself 3 times is going to give me m cubed? So we're going to write that up top. And what times itself 3 times would give you 8? Well, that's a 2, and you fill that there as well. Now, after that, you're going to construct a binomial factor, so leave space because you're going to be filling in a binomial, and a trinomial. So give me a small parentheses and then a bigger one. And then you're going to fill in your signs. The signs going across are going to be minus, plus, plus. Fill in the shell of it because then putting in the numbers is going to be really easy. Now, the first time that we do this, we're going to walk it through together, and you're not going to be writing this down. I'm going to show it to you as sort of baby steps, and then we'll give out a simplified final answer that you should be able to do in your head. So this next step, I just need you to go through and watch. There's a binomial factor and a trinomial factor. The binomial is going to be left minus right. When we talk about left, it's the cube root of the left. The right is the cube root of the right. So my binomial is going to be left minus right. So in this case, to start off, again, don't write this down yet. It's just going to be m minus 2. Left minus right. Now, to get the trinomial, it's left squared, left right, right squared. So what would I get if I took the left and squared it? M squared. Left right would be m times 2 with a plus there. And then on the right-hand side, I would have 2 squared. Now, in reality, can you go through, as enriched students and as honor students, should you be able to go through and simplify this trinomial down? Absolutely. This is going to be m minus 2. Hands up, please, if you can tell me how you'd express the trinomial and condense that down. Because you wouldn't list it out like that. What would you do just to simplify it down and write it, I guess, in a more standard form? Go ahead. There you go. You can go immediately to that step. That's where you should be going. With that in mind, I want you to give a try, please, on question B. List out, they're not perfect squares, they're perfect cubes, so list out what those perfect cubes are going to be above, or those cube roots, and then do left minus right, left squared, left right, right squared. Cube root of the left would give me a 3x. Cube root of the right would give me a 2y. So my binomial factor, hands up please if you can tell me what the binomial factor of this would be. We'll wait for 6. We've got 2. Really? 3. 4. What do you want to say?
3x minus 2y.
So we'll fill that in first. That's my binomial factor. Now, on the trinomial factor, this is where some of you are going to screw up, and it only happens the first time. It's going to be left squared, left right, right squared. This is where you're going to screw up. What do I get if I take 3x and square that? 9x squared. There's a lot of you, let's say this, who left it as 3x squared? Yeah, that's one. And you're not going to make that mistake a second time. And I'm guessing you're probably going to want to erase what's at the end as well. Because if you made it in the beginning, you probably made the same mistake at the end. Now I'm going to take, so I did left squared. Let's do left right now, which is going to be 3x times 2y. That would give me a positive 6xy. And now what are we going to fill in at the end? 4y squared. Because remember, you take the 2 squared and the y and square it. Questions on that? Now, we just did a difference of cubes. You can do a difference of squares and a difference of cubes. You can't factor down a sum of squares. You can factor down a sum of cubes. Take a look at what's there. This is the factorization pattern. It's very, very similar, but slightly different. Hands up, please, if you can tell me what's different between the factorization pattern from a from a difference of cubes to a sum of cubes. There's one thing, one component that's going to be different between those two. The pattern is the same. Go ahead. Yeah, the addition and subtraction changes. So if it's minus, it goes minus plus plus. If it's plus, it goes plus minus plus. There's still a binomial factor. It's left, right, then left squared, left, right, right squared. Go through right now with that in mind and view out question A. With that in mind right now, please go through and finish question A. Cube root of the left would give me an r. Cube root of the right would give me a 3. Hands up, please, for the binomial factor. We'll wait for 7 of you. We got 1, 2, 3, 4. What do you want to say?
R plus 3.
Terrific. Who thinks that they can give me what the trinomial factor on this is going to be? We got 1, 2. What would you like to say?
R squared minus 3R plus 9.
Do you want question B right now, please? Your binomial factor, hopefully we're not messing that part up. Hands up, please, if you can tell me what the trinomial is going to be on this one. You want to say? When people make the mistake, it's when you square the 3's lead. Go through right now, please, and try out question C. Question E is probably one of the toughest that we're going to go through and do today. And if you get that, well, your binomial factor here, I list this out. The cube root over here is going to be a 5t, and over here it's going to be a 6s squared. So my binomial factor is going to be 5t plus 6s squared. Who can tell me what they think our trinomial is going to be? No takers at all. You got 1 to wait for 5. Two, 3, 4. Can you read that one more time so I want to make sure I heard you right? You said 25 t squared, right? Close. What's that middle sign going to have to be? Minus, and what do you have at the end though?
Plus 36.
Perfect. Perfect. Just remember those signs going across. Yeah.
Why is 6s not like 3 minus squared?
What are you talking about? This over here? Because you're saying what times itself 3 times is going to give me that expression. So the 6 you get, or sorry, the 216 comes from 6 times 6 times 6, right? What do I have to multiply by itself 3 times so I get an s to the 6? Now, what were you saying it should be? Did you want to say it was s cubed?
Yeah.
If I had an s to the third times s to the third times s to the third, what would I get going across if I multiplied those 3 together? What's that? No. If I took s to the third, what do you have to do to those exponents? You'd have to add them.
Oh.
So if I multiplied s cubed times s cubed times s cubed, this would not equal s to the 6, it would equal s to the 9. Okay? That's why that's what it is. And again, these powers are very, very awkward to go through and deal with. This next one, this is why we spend all that time writing out what those perfect cubes are. This is, again, a sum of perfect cubes. The cube root of what we have on the left is going to be the quantity x plus 2, and this would be a t. So I've got a binomial and a trinomial. The binomial is going to be the part that's probably the easier one, and technically by making the binomial, it's going to be a trinomial. It's going to be left plus the right, so I get this. Now I need to do, when I'm doing this, I need to take the left squared minus the left times the right plus the right squared. So I list it out as this, the left squared minus the left times the right plus the right squared. And again, brackets are just secondary parentheses. This is one of the things that, and I don't know if I'm expecting too much from, but by now the hope is that you are not saying this, because this is inevitably some people's answers. It doesn't happen that much in Regents. It happens a lot in Regents, hopefully not in Enriched. Those are not equal to each other. If you have a binomial squared, you have to write it out twice. The reason being, now you'll see why that's wrong. You don't just square the pieces because it's a binomial times a binomial, or a double distribution, which we'll say is a FOIL. We've got a first, outer, inner, and last on it. My first terms multiplied together are x squared. My outside terms are going to give me a positive 2x. My inside terms would give me a positive 2x. And my last terms would give me a 4. So if I'm looking to expand this and simplify this out, this is not a 1 in front, so we can drop the parentheses. This would be the quantity x plus 2 plus x, or it simplifies down to 2, x plus 2 plus x. Now this next piece is when it's going to get long and a little bit difficult. It's the expectation that you can FOIL that part out in your head. So if I take the quantity x plus 2 and square it, or multiply x plus 2 times itself, that expands out to be x squared plus 4x plus 4. Now the rest of this in the middle, again, there's a little bit of algebra, know-how that you're going to have to impart on it. This t can sort of bounce in front, and we're going to distribute out a negative t to those two terms. Or you could distribute out a negative to them and then multiply by t. It doesn't matter which one you do. So this would be negative xt, and then a negative t times 2 would be negative 2t, and then plus at the end you got t squared. Probably the most difficult one that we'll do today. Questions on that? All right. Let's bounce over. We're going to do some profoundly easy ones. Okay. Yep. Go to page 3. The first thing that we should always be checking for is a GCF. And there's a lot of these when I go through and I get lazy and I forget to tell you that in my head the first thing I'm looking for is a GCF and I find it. Looking at that, I've got x squared plus 2x minus 35. There is no GCF there, nothing you can take out from everything. So the next thing I check, is it a difference of perfect squares, and it's a trinomial, so that doesn't work. It's not a sum or difference of perfect cubes either, because again, there's 3 terms there. So what I have to say is, well, if there's a 1 in front, I can break this up into 2 binomials. The value that starts this off is going to be in x, so I fill in x in the lead position on both. I need numbers that multiply to 35 that I can get a 2 from. So I'm going to go to the side and say I've got 35. Now, I in the beginning like to list out, when I teach this at an introductory algebra, I always have kids list out all the factor pairs of the number. So if I'm looking at 35, hands up please if you can tell me one of the factor pairs for 35, because everyone gets the easy one. What do you want to say? 7 times 5. What's the other factor pair for 35? Everyone always forgets this. We got 2 people. It's the easiest one. Good. So I listed out as 1 and 35 and 5 and 7. Now, which one of those how can I arrange it? So I guess, which one of these pairs can I get a 2 out of? It would be the 7 and the 5. Now you've got to tinker with the signs because they have to multiply to give you negative 35, which means that there's a switched sign in it, or they're not the same sign. So if I did that, the factor pair that works is going to be x plus 7 and the quantity x minus 5. Now when I do this, here's a relationship really that you have to understand because we're going to undo it in just a second. If I have an x squared in front, whatever that value is, in the FOIL process, you get it from multiplying those two together. To find the value at the end, which we said was negative 35, I get the negative 35 by multiplying the last values. Where does the 2 come from? Well, the arrangement of those last values and the expansion itself. Go through right now, please, and do out A and B. Go through right now, please, do out A and B, and we'll ask for volunteers in a second. Again, these, especially if you're really an honor student, these should be taking 10 seconds. Hands up, please, for A. If you can tell me what the factorization of A is going to be. We'll wait for 7 of you. I've got 1. We're up to 2, 3, 4, 5. What do you say, please?
A.
Mm-hmm.
2 plus 5 and quantity of 2 minus 6.
First term's work. Outside gives you negative 6. Inside gives you positive 5. That goes to negative 1. Terrific. Hands up, please, for question B. We've got 2 of us. 3, 4. Okay, you said it.
The quantity of W first. W plus 8 and the quantity of W.
The quantity W plus 8 and the quantity W plus 4. Outside, inside gives you 4W and 8W. Last is going to give you 32, so that's terrific. How about, for example, 2? Hands up, please, when you can tell me what that factors to. We got 1, 2. What do you want to say?
M plus 1, M plus 7.
Let's give it a try. We got m plus 1 and m plus 7. So first terms give you m squared. The outside gives you 7m. The inside gives you 1m. What's 7 and 1 going to give you? 8.
Or I meant negative 1.
Now, let's do that one. We go through, we'll change that to a negative 1. My first terms give me m squared. The outside gives me positive 7. The inside gives me negative 1. So that gives me the 6 that I'm looking for. And at the end, I got a positive 7. Is that right? What did I say that was wrong? The positive 7, because I've got oscillating signs. What's the problem with this? It doesn't factor down. What's it called if something can't be factored down? There you go. By the way, it says it right next to the example. The thing that I'm fascinated with, we had this discussion about why you all tend to either, and especially Reached it, they hate factoring and or they're not good at it. And you all, because it's like, anytime you ask a question about a line, people like develop this uncontrollable impulse to just start yelling out y equals mx plus b. Like I go, what's the formula for slope? Y equals mx plus b. Because they drill it into your head over and over again. Is the formula for slope y equals mx plus b? Is that the case? What is y equals mx plus b? Did you guys take GL? Allegedly? I'll bring Welker over right now and ask him if he knows. Did he not show that to you? Did he not tell you what y equals mx plus b is? It's going to give you a line. What's the formula for slope? Well, it's the change in y over change in x, or y2 minus y1 over x2 minus x1. When we were talking about factoring, I went over to one of the 8th grade teachers and go, let's see, what you do. Because the stuff that I pulled, this is actually from a calculus book. And I sat there and I was like, what do you do with them for factoring? Let's just see what you do. They showed me the sheet, and there was like 500 factoring questions on it. I'm like, that's great. And then I'm looking at them, and I went home and I started doing the answers, and I got up to like, I think I got to like 87. And I went back and I go, does every one of these factor down? I go, oh yes. Why? Like, you're going to encounter numbers that are prime. Like, you waste all of this time coming up with all of these examples that work. You're supposed to encounter some that don't work. Does this factor down? No. We're going to have quadratics that don't factor down. You have to be able to recognize the ones that don't, not just the ones that do. Take a look at the next one here, and this is why, if you paid attention to before, this yellow and blue relationship, I normally use green, down here, it comes to fruition, and we need to see it over here. Take a look at example 3. Now, we're factoring a trinomial with multiple variables, get over. You're going to have two factors here. Now, the way to check to see if something factors down, a quick way to check, what is your leading coefficient? Hands up, please, when you tell me what the leading coefficient is. No? 1. The leading coefficient is the number in front, okay, of your square term. So this is a 1 and this is a negative 16. So I take the outside numbers, so that's going to give me 1 times negative 16. All right, are there numbers that multiply to negative 16 and add to the middle value, which is 6? Are there numbers that do that? Yeah, if there are, then it can factor down, or at least it's a good candidate to factor down. So what I'm going to do is say this does factor down, and I'm going to list out 2 sets of parentheses. And now I'm going to construct it and see if it works. I'm going to sort of take a guess and see if that works. I've got something I'm putting in the yellow here, something in the green. Who can tell me what I want to put in the yellow spot? Because remember, that yellow position needs to give you what the x squared is. So hands up, please, if you can tell me what I need to have in those yellow spots in order to make this sort of build up to what I'm looking to have. What's that? You need an x in both of them. That's terrific. So I'm going to fill in an x here and an x here. Now the green needs to give me a negative 16a squared. There's a problem with that. I've got multiple candidates for that. Who can tell me some candidates that I could fill in that are going to give me a negative 16? I'm going to say 16. We can play around with the sign. What are candidates for the green position that are going to give me a 16a squared?
8 and 2.
We could do 8 and 2. That's not it, though. What else could I do? Sorry, and it should have been 8a and 2a. What's the other candidates that I did?
4, 8, and 4.
Perfect. Now, which one out of that candidate pool do I want to pick? Do I want to do the 8a, 2a, or do I want to do the 4a, 4a? So let's go through and fill that in. So again, you're building up to it. Now, play around with the signs. And hands up, please, when you can tell me what the final answer that you're going to want to have there is. We've only got 4 so far. 5, 6. What do you say, please? There you go. Was that difficult for you? And by the way, and again, forgive me, I get to be very lazy at times. The first thing you always check for is what? GCF. Is there a GCF here? No. Understand, by the way, when we say something's common, that means every piece has it, not just most of them. Take a look at the next one. There is a GCF when I start off example 4. Hands up, please, if you can tell me what the GCF for that trinomial expression is going to be. I've only got 3, 4 of you. These things should be automatic. What do I say? Perfect. So I'm going to take out 16. What are you left with when you take that 16y out?
2y minus 8.
Am I done? Hands up, please, if you can tell me what your final answer is going to be. I want the whole final answer. We've got no persons. 1 person. Thank you. 2 of you. Thank you. 3. Thank you. 4. Thank you.
16y times the quantity of y minus 3 times the quantity of y plus 1.
That's outstanding. Perfect. Questions on that? Now, I'm going to tell you this. Example 5 is probably the only one that we've done so far that may be new for you, at least the weaker Algebra 1 teachers over at Friday, stay away from these. Taking a look at what's there, please. Who can tell me how example 5 is different than the others that we've done so far? How is 5 different than the ones that we've done so far? I'm not asking you to factor it down. I just want you to tell me how it's different. And I love how we're using math-appropriate language. The number in front of the term of highest degree is your leading coefficient. My leading coefficient now isn't 1. Is there a GCF for this? No. So this is going to be really awkward, and you are going to curse me for putting in a 12. You wish that this was an 11 or a not a 9. You wish it was an 11. You wish it was a 7 or a 13. Let's play it forward. Does anybody know why I hate this? Why I want to see a 91 here before I went through and saw a 12? Why is 91 easier to work with factoring than a 12? The 91 is prime. Look at all of the choices that we're going to have. I'm going to build out my 2 sets of parentheses over here. And by the way, and this is not to trivialize it, but there are a lot of people who are very, very brave. The police, the military, the firemen, the EMTs, all of the servicemen and women, so brave. Heroes have more courage than I have inside of me. And underneath those people, slightly, are people who do math and pen. I mean, that's the kind of brave I will never understand. This is why I'm a strong advocate for not doing math and pen, because we're going to be factoring, the way that we're doing this is called guess and check. You're going to be guessing and you're going to be checking, and if you're guessing and checking in pen, that means you're constantly going through. If it doesn't work, you're going to be erasing, and your paper starts to look like, let's say, sloppy, to say the least. Now, we've got to have values in front here that are going to multiply to give you 12R, so 12R squared. So who can tell me one possible candidate for those yellow positions? Hands up, please, if you can tell me just one pair. Go ahead. Who's got another one? Okay, who's got another one? Okay, so we've got all those. I think we've exhausted all our pairs. So this, we've got these two here, and then it was 12R and 1R. Now, then we need to list out the factors of 2. That's kind of easy because it's only 1 and 2. And we also need to have a positive sign and a negative sign. So these are all of the candidates that I'm sort of tinkering around with. Now, as of now, I think there's like 12 options. Maybe we'll make this a little bigger. Okay. So there's 12 options. You're going to be taking guesses as to what these are going to be. And then you're going to foil it out in your head and see if it actually works. Now, looking at what's there, let's start off with, let's say, 6R and 2R. So I try this one, right? And that means, let's do a 2 here and a 1 here. And then let's do, I don't know, plus here and a minus here. So now, I wrote that down on my paper. I'm going to see if this works out. I've got 6R times 2R. What's that going to give me? 12R squared. So far, I'm great. On the outside, I've got 6R and 1R, so that's 6. And then the inside, negative 4. So what's 6 minus 4? Did that work? Now, I'm going to say this. I knew that it wasn't going to work beforehand. Because what does the answer have that the question doesn't? Hands up, please, if you can tell me. Look at those answer choices. The one, my candidate that I tried has something in it that's not in the original. What does mine have that the other doesn't? No? We've got to have oscillating signs in there. No? Common factor. Does the original have a common factor? Then why would the final answer have one? What's the common factor there? 6R minus 2. I can take a 2 out of this. I can't take it out of the beginning. So immediately I know that this can't go together. That's why when we go through and say there's a ton of guesses, you've got to be able to narrow the candidate list down though. You could FOIL that whole thing out, but I knew it wasn't going to work to start with. So maybe let's try, let's try maybe a 1 here and a 2 here. Now is that going to work? Well, I've got 6r², that gives me 12r². This is going to give me a positive, what? What's the outside? 12r, the inside is negative 2r, so is that giving me the negative 5 I wanted? Now, that means I'm going to throw out and ditch the 6r and the 2r. Now I'm going to try again. So let's say I try with the 4 and the 3. Can that go here? Can this candidate go here? Why? Common factor. So if I'm going to try, maybe this and this works. Your job now is to finish this out. Try to find ones that are going to work. We'll wait till we have 6 people who can tell me what the full factorization of this would be. We've got 1 so far. Thank you. 2. You take your guess and you just give your FOIL. And let's see where we get. 2 of us. 3. 4. We're getting there. And again, there's no magic to it. The more you do it, the better you get at it. Obviously, 12 is a really awkward one. By the way, you may want to throw out the 4 and the 1. 4 and 3. Try 12 and 1 if you get stuck. You just keep doing these iterations until you get ones that work. We still have 1, 2, 3, 4 of you who can go through and tell us what that would be. 5. What do you want to say?
Can I use 4r plus 1, because if 1 use 3r minus 2.
All right, so let's check to see if that guess is right. 4r, 3r gives us a 12. The outside is going to give you the negative 8. The inside gives you a positive 3. Last thing to make sure of, 1 times negative 2 gives us the negative 2, and that works. So is it a lot there? Absolutely. Now this next one should be a little bit easier. Remember, this goes here, and then this goes here and here. Who can tell me what has to be in the yellow? You're going to love this one as compared to the last one. This is a walk in the park. Yeah. 1 and 3. So let's do, let's do the 3 first and then the 1. Play around with it to see if you can get what the final answer would be. Hands up, please, when you can tell me. Remember, those green positions, you need something that's going to multiply to give you a 2. You know that they're plus because there's pluses throughout. We got 1, 2, 3 of you. 4, thank you. 5. Yep.
If 1b is 3x plus 1 times 1b is x plus 2.
Let's see if that works. First term gives me that. Outside gives me a 6 and then a 1x, so that gives me the 7 I was looking for. When we're doing it out, those are the 2 different guesses that you could go through and take. And they don't work out. They're not all created equal, let's say. All right? Now, if I'm you, I bounce over. We didn't get to any of this just yet. Taking a look at what's here, if I'm you, I would make really, really sure. And by the way, I think actually, I don't know. I personally, if I were you, I would get maybe from this set, I'd get like 10, 12 of them done. You've got to find what works for you. Some days I'm going to give you a bunch to do. Some days I'm going to say you've got to find what works. Did you do that type of factorization before? You all did? Okay. There's some classes that did not. So I'm glad that you go through and have that. Take as many reps as you need. What's the first thing we always check for, by the way? GCF. Make sure you know the sum and difference of perfect cubes. That's on your assessment next time we meet. Sum and difference of perfect cubes is on your assessment next time we meet. Have a wonderful rest of your day. Yeah.
Yeah.
Okay. Mm-hmm.
Can I go in and try to do
Like, what does the error say? Does it show you, like, is that I'm not able to log in, or?
How do you do this, actually? Here, I'll show you.
Start.